everybody, Harbin here, and we're talking video notes 2.2, the periodic table. So make sure you read these 3 bullet points. In your book, we're looking at chapter 4 and chapter 11, just a few pages there. So there'll be some questions at that. Hey, guess what? It's the 16th of the month, so my favorite magazine is coming. So the 16th of February, I get this magazine, the 16th of March, etc., etc. Guess when it comes? Periodically, they're called periodicals. And periodic means repeating. So there's a periodic law that says when you arrange the atoms by atomic number, the trends will repeat periodically. So what are some things that you're going to know about? Well, you're going to know about the size of the atoms, the charge of the atoms, just like the days of the week repeat in a month. So, you have Monday, Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and then the next week it repeats. But it's just different days, kind of like that. Go across, there's a pattern. Next row, there's a pattern. Next row, there's a pattern. Periodic. So, this is called a period. Going across, period. And then, up and down, they're called columns or families, right? Columns or families. And so this is column 1, and this is column 18, but sometimes we label them by A groups, and then it's 1 and 2, and then over here is 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and this is column 13, but we also call it 3A, 4A, 5A, 6A, 7A, and 8A. Okay, so you can number them 1 through 18, or you can number them with these A groups, and we're going to see some patterns, but columns or families or groups. All right, so who's in your family? Beryllium, magnesium, calcium are in a family. Periods are rows, okay? And we have 7 of them on our periodic table. Now you might be saying, what about these ones? Well, this, if you see 57, this is 58. This is part of row 6, and 89, 90, this is part of row 7, but they just go up here in the periodic table, okay? So, series. There's some series on the periodic table, like this is called the lanthanides and the actinides. Those are series, and they're special, kind of like The Simpsons. Okay, so it's the history of our periodic table. Well, people were trying to arrange the elements as they were being discovered, and what Dmitri Mendeleev did was he saw trends when he arranged them by mass. Now, that's close to what we do today, but we actually use atomic number today. But his arrangement was pretty powerful because he predicted elements and their properties before they were discovered. Today, we use atomic number. Okay, so the periodic law says that patterns repeat when you arrange them by atomic number. The original periodic table that was used very often was by atomic mass. All right, so charge is periodic. The elements in this group are metals, and when they make bonds, they lose electrons. So the charge for this column is going to be a +1 charge. Charge for that column is going to be +2. In this column, you can see I'm drawing a stair-step line. In this column, the charge for metals will be +3. This column, they don't make bonds because they have a full set of valence electrons. This column is going to be a -1 charge, -2, -3. And usually the elements in this, there's some metals and some non-metals. They have variable charges, but a lot of times it's a 4, +4. Okay, so charge is periodic. So that means if you go across this way, you see that pattern. If you go across this way, you see the same pattern. Okay, and again, this number at the top, if we label them by the A group, you'll see that they have charges that correspond to the ions they're going to make. So this is group 7A. They have 7 valence electrons, so then you need 1 more to have 8. So they'll make a -1 charge, gaining 1 electron. Okay, so regions of the periodic table. There's metals, nonmetals, and metalloids as big regions. So again, we need the zigzag stair-step line. It starts on the left end boron and walks down the stairs. All of these, except for hydrogen, are considered metals. All of them, metals. So the properties they have are they're shiny, they conduct electricity. When they're solid, they are solid, except for mercury. Mercury right here is a liquid. They're malleable. It means you can hammer, bend into shapes, make into shapes, into shapes. And they react with acids. Okay, so that's the metals. Find your favorite metal. Oh, look, it's nickel. And then you note that it has those properties. So that means everything on this side, even these, have those properties. So then you got your nonmetals over here, all right? So they're not shiny. They don't conduct electricity. Some of them are gases, some are solids, some are liquids, all right? Then there are metalloids. So some along the stair step actually have properties of both metals and nonmetals because they're in between. They're tweeners. All right, more regions of the periodic table. Okay, so we got our lanthanides and actinides. So lanthanides and actinides. These are called transition metals because you see all properties of metals in here. Okay, and then these are often referred to as inner transition metals. Okay. Inner transition. Lanthanides and actinides, and these are called transition. Okay, so we got to find these regions, transition. Good, let's see what else. Ohana means family. Hey, Lilo and Stitch. Lilo and Stitch say family means nobody is left behind and forgotten. What chemists say families are columns on the periodic table. All right, so a periodic table column is a family. Family. All right, also known as a column. They have, or a group. They have similar properties, and that's why they're in the same family. Okay, so lithium, sodium, potassium, rubidium. If you look at them, they're all shiny metals. Woohoo! That's a property of a family. Hydrogen's an orphan like Stitch, though. So learn the names of the families of the A elements. L are elements in the A group. So I've been calling these 1A, 2A, 8A. It's easier to do it this way so you don't. You can write it on a periodic table anytime you have one. So we have some names for those. So group 1A is called the alkaline metals, except hydrogen's in the family by itself. Alkaline earth metals are group 2A. Okay. The aluminum family is group 3A. It would be, usually you name them after the top. Carbon family is group 4A. Nitrogen's 5A. Oxygen's group 6A. The family is named after the first element. The halogens are 7A. All right. So these are the halogens. Halogens. They have a special name. And these are the noble gases. Noble gases. So usually an A group family is called a representative A group because they represent all of the trends in the periodic table. And so some of the A group families have special names. This family is the alkali metals, and these are the alkaline earth. So alkaline, come on, Harbin, spell it right, earth metals. All right, so those are some special names of families. Noble gases of group 8A. And they don't react, so they're noble gases. They're too good for everyone. All right, so if we're in the same family, we're going to have similar atomic sizes. We'll learn more about that in the next video. They have similar reactivity for their row. All right, so if lithium reacts with water, so does sodium. So does potassium. Okay, we'll have identical charges for the row. So if lithium has a +1 charge, so does sodium when it makes an ion, so does potassium. They'll have the same ending electron configurations. All right, so remember how we were looking at valence electrons? Valence electrons, same number. Oops. And they'll be different from their neighbors to the left and to the right. So they're not going to be like the ones on the left. I mean, maybe similar to some things, but they'll have their unique family characteristics. So, are these traits periodic? Atomic mass. So if I go across this way, atomic mass increases, and then it increases that way. So yeah, charge, +1, +2, 0, -1, -2, -3. We go across this way, and then we go again across the period, it charges. Reactivity. Okay. So as you go this way, you see a pattern, and then you do that in the next row, you see a pattern. All right. So periodicity is due to similar electron arrangements. So we spent a lot of time talking about where the electrons are, the electron configuration, and it's valence electrons that help us predict how things are going to react, okay, and how they act. So to review, families are groups and columns, up and down. Periods go across, and traits repeat. Remember what comes at the end of a sentence? A period. And so a period goes across the periodic table. Memorize the groupings, like the A groups, A, names, that kind of stuff. Periodic means repeating. Periodic means repeating. Know your properties and what's the periodic law. And remember, periodic law goes by atomic number. That's a nice introduction to our PT, and we're going to learn more about it. So make sure you read these sections in Chapter 4 and these pages in Chapter 11, and then look at some of the things on page 90 and 91. And then make sure you know the groups. Page 99 has something to look at. So, and page 328. Use your book to help you. They have great pictures. They can draw better than I do. They're professional book writers. Okay, so make sure you can know the regions on the periodic table and groups, properties of the different sections, and guess what we'll do in class? Working on that. So peace out, peeps.